Hi, mathematicians. Oh, look what I got for you, Tony. I know, donuts. Uncle Tommy already ate a half a dozen. You know how many that is, my friends out there, right? A half a dozen? If you said 6, you're correct. Tony is here, my little math monster. I'm really glad you're back in the room. Tony, today we're going to be talking again about using place value understanding when we add and subtract. And so when we were together yesterday, or maybe you watched the video just a few minutes ago, Tony, we talked about different ways of adding double-digit addition. So the one way was new groups below. So if you were making a 10, you could put your 10 below. Or if you made a new 10, which means you regrouped and made a 10, you could also put that new 10 new groups above. Another way of when we're doing our double-digit addition is a lot of boys and girls will also show all totals. Absolutely. Thank you, Vanna Math Monster. So that is another method. And finally, for my friends, would you grab that, Tony? Would you take that off? Thanks. Sometimes we still need to show a proof drawing, which is absolutely fine. We'll sit there, we'll make a picture of each of our numbers, and then we will find those totals. I'm going to grab this one just so that I can make sure that my parents and my friends at home understand. Again, we made a 10 here, but what happened here with this 90, if I take one more 10, I've made a 100. So maybe that's what we also have to make sure all of our friends know, is that we made a 100 and we have 1, 2, 3 10s. And that's how we have 130 with a 6. That brings back our expanded notation of 100 plus 30 plus 6 equals 136, because our 10s help us understand it. That visual, that proof drawing is very powerful. Thanks, Tony. So friends, we're going to use this understanding to get us into 3-digit addition. We are dumb. Tony, we're jumping into that deep end. We truly are. And when we get into that deep end, my friends, we are really going to have to swim deep and hard, but we're not going to be alone. We're going to be together. Tony, would you join us right now? Awesome. Tony's going to join us right here on the carpet. And so, my friends, she's going to be doing this problem right along with you. 376 plus 245. Now, friends, when you're putting these 3-digit numbers together, it's important for us to understand that place value. If you've noticed, my 6 ones is directly above my 5 ones. I have my 70 above my 40 and my 300 above my 200. Let's look at Tony's board. She lined hers up quite well. Friends, it can also help you on the back. If you've noticed on the back of your boards there are squares, you can use those to line up also using that for place value. I've had lots of boys and girls use that too in the past if they're having a hard time keeping their numbers lined up based on place value. So friends, let's go back to what we already know. We know that we can add this with showing all totals. We can add this by putting groups above, putting groups below. We can even do a proof drawing. Friends, I'm going to start off with a proof drawing. Would you join me in that? Let's make a proof drawing. So on your boards, let's have you do that, and I will as well, and so will Tony. I know that my number has 3 100s. 50, 60, 70. It has 7 10s and 6 1s. If you've noticed, friends, when I do my visuals, I always make sure that I use a 10 frame with my ones place. It helps me keep track of my 5, and then one more is 6. And my 3 100s are basically my quick 100s. I have 2 100s here. I have 4 10s. I use my quick 10s for that because I know that's 10, which means it's 10 ones linked up, and that makes a 10. and then my 5 extra ones. Now, Tony, did you make a visual? Awesome. I'm going to look at yours. Tony made her row of 6 right here. Looks like she's got 4 and then 2 more. That's fine. That's 6, and then she has her 5 here. So she has her visual also. So friends, I'm going to start off right away. I know that 6 and 5, when I put mine like this into a 10 frame, I right away see a 5 and a 5, and I make a 10. I also know 6 and 5 is 11. But I've made a 10, my friends. That's my 10. I'm going to make a 10 right here so I don't forget. And then I'm looking at my 10s I have here. So I have 70, 80, 90, 100. Friends, I made a 100 with my 10s. So I have 70, 80, 90, 100. I'm going to take these 7 10s and these 3 10s. I made a 100. I still have an extra 10 right here. But I made a 100. I'm going to put 100 there so I don't forget. And then I have 300, 400, 500. Now, friends, what I've done in this visual is I've grouped them into hundreds and tens. I can now look at this. I have a 10. I have a 100. Wow, I'm going to count up my 100s. 100, 200, 300, 400, 500. I made a 100. 600. And I'm putting that in my 100 spot, but I'll even put it here so we can remember. 600. And then I have a 10. And I have this 10. That would be 2 10s, which I know is 20. And then I have this 1. So I made an expanded notation of my visual. Let's see if that makes sense. 621. I'm going to try that now, friends, with another method. I'm going to use my new groups above to see if I agree. So I'm going to get rid of that 600 here. That kind of had my visual here. Okay, so that was my visual. So 6 plus 5 is 11. I know that. That leaves 1 behind, and I have a 10 that I bring to my tens place. Now I have a 10, a 70, and a 4 at 40. I can look at that as a 7, a 4, and a 1. I'm fine with that, friends. But remember, those